All right. So here, all right, I want you guys to know end behavior of a polynomial, all right? And there's three different ways you can look at it. You can look at it from a function, you can look at it from a graph, and then you can just look for the end behavior statement itself. So let's go ahead and get started. Remember, there are four different types of polynomials, all right? So here, I said state the end behavior of the following polynomial function. I gave you y equals 3x to the fourth plus 5x to the third minus 13. So the big thing you're looking at when you're looking at end behavior is you really only care about that first term. So here I see that it's 3x to the fourth. I'm just going to give you guys a quick sketch of this graph, all right, because I think that'll help. This would look something kind of like this. And the reason I know that is because it's a positive leading coefficient. Positive leading coefficient. All right, and then it's also an even degree. So the degree of this guy is 4. All right, which means my end behavior statements, which I'm going to go ahead and write the answer in blue. All right, as x goes to negative infinity, y goes to something, and I'm going to fill in that blank in a second. And as x goes to positive infinity, y goes to something else. All right, so you're always filling in the blank with either positive or negative infinity. Here, because it's a positive leading coefficient and it's even degree, right? As x goes to negative infinity, y is going up positive, so it's positive infinity. And then as y is going positive, it's also going to positive infinity. So when it's an even degree, the y value should match. So you're either going to fill this in with positive infinity or negative infinity. So that's a good tip that you can know. But we're going to go ahead and move on to this guy. It says state the end behavior of the following graph of the polynomial function. All right, so here I gave you a graph, end behavior. So they're all going to look like this as x goes to negative infinity, y goes to something. As x goes to positive infinity, y is also going to something. So here, as x goes negative infinity, right, so as y gets really small, it looks like y is going up towards positive infinity. And as x is going to positive infinity, it looks like y is going down, so that goes towards negative infinity. And I could go ahead and tell you this one would have a odd degree because the end behavior statement doesn't, the y's are going to different values. And this one would be a negative leading coefficient, all right? And that's something that I hope you guys start recognizing that pattern of. But we're going to go ahead and move on to this last one. It says determine the degree and the leading coefficient. So can you do that from just the end behavior statement? So something that might help you is to give a sketch. I'm actually going to move this here. So it says as x goes to negative infinity, y is going to negative infinity, so it's going down. And as x goes positive infinity, y is also going to negative infinity, so it's also going down. So the degree of the polynomial is, right, so since both the y's match, we know that that's even. And the leading coefficient is negative in this case because instead of opening up, it's opening down. So that's like a sad face, right? Sad face. Sad. That's kind of scary actually because I chose red. But anyway, yeah, so I'm hoping that you guys are able to figure out the end behavior of a polynomial from the function, from a graph, and tell me more about it. But there you have it.